Welcome to multiple choice question 1 of the 2009 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of a CAS calculator may assist in answering this question. For question 1 we consider the simultaneous linear equations as given, where k is a real constant, and the question asks those simultaneous linear equations will have a unique solution provided k is one of the following options. So I'll show you two approaches in this video. The first one is that we know that we will get unique solutions for simultaneous linear equations provided that we have different gradients. So if we want to have different gradients, we'll need to get these two equations in the gradient-intercept form so that we can compare them. So for our first equation, which is kx minus 3y equals 0, I'm going to start by adding 3y to both sides of the equation. So that means that kx will equal positive 3y. And then I'm going to divide by 3 to get y by itself. And we actually get y equals, and it's going to be k divided by 3 times x. So we can see what the coefficient or gradient is there. Technically, there's a plus 0 to say that's what the y-intercept will be, but that's more or less irrelevant for this question and the way it's been asked, because unique solutions just require it to have different gradients and there's no condition for the y-intercept. For our second equation in this system, we want to add the k plus 2y to both sides. So that will give us 5x is equal to k plus 2 in a bracket times y. So therefore, to get y by itself, we're going to divide both sides of the equation by k plus 2. So we're going to have 5 divided by k plus 2 times x. And then technically there's a plus 0 there, but again, as discussed before, that's not relevant for this particular question. So coming back to our initial thoughts about having different gradients, what we now want to solve is the gradient of that first line, which is k divided by 3. We want to solve that so that it's not equal to the gradient of the second line, which was 5 divided by k plus 2. And that's now something we can do on a CAS calculator. On the CAS calculator, go into the main menu. Next, we want to solve an equation. So I'm going to go keyboard and bring up our fraction first so that I can type in variable k divided by 3. And I'm actually going to use the not equals to symbol on the calculator, which you may not have seen before, but it does exist under Math 3. So I can do k over 3 is not equal to. And then the next fraction was 5 divided by variable k plus 2. And then I can highlight that and go interactive, equation inequality, solve for the variable k. And then hitting OK gives k is not equal to negative 5 and k does not equal 3. So therefore, our calculator tells us that k cannot equal negative 5, as well as k does not equal 3. Now another way to write that is that k could be any real number excluding those two values. So with a backslash and the squiggly brackets or the curly brackets, we just list negative 5 and 3 in there. And that's another way of representing that answer, which means that B, looking through our options, is the correct answer. From the examiner's report, we can see that this question did challenge a lot of students, with only 49% of students getting that question correct. And as I mentioned earlier, I'm going to show you a second method of doing this that involves matrices. So once again, just unpacking the important information, we want a unique solution. In terms of our matrix approach, that means we want the determinant, which isn't the discriminant, it's the determinant, to not equal 0. So we'll discuss this idea of a determinant in a bit more detail in a moment's time, but our requirement for a unique solution, just to reiterate that, is that the determinant is not equal to 0. So our next job is to transfer the system of simultaneous linear equations as they are into matrix form. So to do that, we're going to start with a square matrix, and it's going to multiply x and y, and then that will equal another matrix. Then we look at the coefficients of x, which are k in the first one and 5 in the second equation. So we need to put k in the top left position and 5 in the bottom left position, because in a matrix we know that they are the positions that will multiply x. And then in the other two positions we need to put the coefficient of y, which, just be careful here, it's negative 3 and negative k plus 2. So we're going to have negative 3 here and negative bracket k plus 2 in the bottom right position. The equals 0 here and here would technically go in this third matrix, but that isn't relevant for the approach we need to take for this question, but I'll put them there just so you can see what would happen to those values. Next, we want to unpack this idea of a determinant. So if I just say here, if we have a matrix capital A, which has elements A, B, C, and D in those positions, then the determinant of A, which I'm going to write as det A, is equal to AD minus B times C. So therefore, for this question, we're going to take A, which is actually K in the matrix that we have above. We're going to multiply that by D, which is the negative bracket K plus 2. And then we need to subtract away from that B times C. And here we have B is negative 3, multiplying the C value of 5. And we want to solve that not equal to 0. Going back to the calculator, I can now actually go to Math 2 and find the square matrix button. And in here, we want to type in variable K. And then in the top right, we have negative 3. The bottom left element is 5. And then here, just be careful, it is negative, then bracket K plus 2. And then we can highlight that and go interactive, matrix, calculation det. And it will give us an expression for the determinant, which is the same as the one we've written down, just expanded and simplified slightly. And then we want to solve this, again, not equal to 0. So I can use Math 3 and the not equals to sign there. And then we can highlight this and go interactive, equation inequality, solve for the variable K. And then that will give us the same two values that K cannot be equal to. So once again, we find that K cannot equal negative 5 and that K cannot equal 3 to give unique solutions for this simultaneous set of linear equations. So that leads us to the correct answer of B as well, using that second matrix method.